Start.
Now, Ohm's law V is directly proportional to I. If we remove this proportionality sign, we have to multiply with the constant. So V is equal to I into R. T is constant. And what is R? R is known as resistance of the conductor. Now, what is the resistance? Resistance is again an inherent property of any conductor which oppose the flow of current. So, now we will discuss how the flow of current is disturbed or opposed by some mechanism which is existing inside a conductor. So let us think about resistance. So we will go into some details. Let this be the conductor, this is the length, and this is the area of cross section. This is a material, suppose this is a material X. This is a conductor. So every conductor is made up of some atoms, and in an atom there are neutrons and protons present in the nucleus of an atom, and electrons are present in different orbits. What happens to a conductor? The outermost electrons are not bounded by the atom. They are free. So, when the atoms are packed inside a conductor, millions of atoms are compact inside the conductor, and its outermost electrons leaves their atom and moves freely. Again, this is a conductor. There are millions of atoms. Suppose this is copper. So there are millions of atoms of copper, but the electrons of the outermost orbit of the copper are not bounded with the atom of the copper. They move freely inside the conductor. Even there is no potential difference. They move freely inside the conductor. These electrons are called free electrons. When these electrons move, obviously they collide with the positive ion of the copper. Why positive ion? Because electrons have left their atom, and when electrons leave an atom, the atom becomes positively charged, because now number of protons in the atom is more than the number of electrons present in the atom. So atoms become positively charged. When these free electrons move inside the conductor, they move randomly. They move here, they move here, they move here, they move here. When they move inside the conductor, they collide with the atoms of the conductor present in a packed form. Packed form means present in millions of numbers inside the conductor. If potential difference is applied, Vx and Vy, if there is a potential difference, electron starts moving in a particular direction. That particular movement of the electrons, when starts moving in a particular direction with a velocity, in physics we have a separate term for that. That is called drift velocity. So once again, when there is no potential difference, electrons moves randomly inside the conductor. But if potential difference is applied, electron starts moving in a fixed direction with some velocity, and that velocity known as drift velocity. Although drift velocity you will learn in detail in higher classes, you must know only this much, that when an electron starts moving in a particular direction under the influence of electric potential, that velocity with which electrons moves in a particular direction, due to the potential difference, the velocity with which electrons move, that is known as drift velocity. D-R-I-F-T, drift velocity. Now, when electrons are drifted towards a particular direction, when electrons are drifted in a particular direction, the movement of the electron or the mobility of the electron is opposed by this atoms. Which atoms? The atoms which are present inside the conductor. This opposing of the movement of electron is termed as resistance of a conductor. So what is resistance? When an electron moves under the influence of potential difference, the movement of the electron is opposed by the atoms, or more specifically the positive ions